So welcome to the R tutorial. We'll be primarily focused on the ggplot2 package. So it is basically a graphics package that is in R that allows you to do simple plots like bar plots, line graphs, time series, and so on. So this tutorial primarily focused on this package. Just a show of hands, how many of you are actually familiar with the R programming language? Okay. like not too advanced, or like just intermediate, or like never used it before? Okay. Basic. Okay. So yeah, so I guess this tutorial is really perfect for you guys. It's a little bit different from your regular R tutorial because the regular R tutorial you see will teach you how to do R programming, but this one will primarily focus on this package, and you'll be able to create plots that look a lot nicer than if you plot them in a regular R tutorial. So let's get started.
Okay. Oh. Okay. Try now. There you go.
So like I said, this tutorial primarily focuses on the ggplot2 package, as well as the comparison between what the graphics look like with this package as compared to the base R graphics, base R plots. So that's the introduction to the ggplot2. And then we'll primarily also look at some of the data frames and the simple data sets that we'll focus on in this tutorial. And more importantly, this will primarily focus on several different types of graphs. So like the scatter plot, the bar plot, the stat bar, histogram, and box plot. I find it much easier to go through examples on how to create these plots rather than give you like definitions on all than the ones that you see on the cheat sheet. So it just tells you, okay, this is how you code it, but does not go through like several examples. So these examples do build up, but not to like such an advanced extent. So you'll be able to follow very easily. So even if you have no experience in R, I don't think the syntax will give you any trouble in learning ggplot2. And then there's some cool time series at the very end to round off the tutorial, as well as some other tips and functions, which I think are quite good. Those I actually wish that I knew when I started off ggplot2, so I included some of them at the very end to round the tutorial off. So ggplot is an R package for data exploration and producing plots. It produces fantastic looking graphics and allows one to slice and dice data in many different ways. It can serve as a replacement for the base R graphics and contains a number of defaults for web and print displays and common skills. So since 2005, ggplot2 has actually become widely used in industry as well as in typical statistical analysis. This tutorial primarily focused on how to analyze data and how to display them, rather than the statistical analysis aspect of that. And in contrast to base R plots, ggplot2 allows the user to add and alter components in a plot at a high level of abstraction. So the only downside to this abstraction is that the computational cost. So if you have a large amount of data, ggplot2 will run a bit slower than the regular plot function in R. So that is the only downside I would see to this. And if you have like 500,000 data pieces, which I thought you will ever see unless you work in some high frequency training environment, unless that's your circumstance, then ggplot2 will be able to plot your data very easily. But if you are looking at 1 million data pieces, then this will not be a good aspect for that.
You don't need to point it to.
Oh.
Just.
Okay. Cool. Okay. So the components are ggplot2. It is based on the grammar of graphics. So basically, it is the idea that every graph can be built from the same types of components. So a data set, a set of geoms, which are basically visual marks that represent data points, and a set of coordinate systems. And to display these data values, you can, for instance, specify the size of your points, coloring, X and Y locations, your legends, and the different categories of your data. We'll go through some of the uses of these components by, like I said, by example. So we'll build them up one by one based on bar plots, line plots, and so on. And you'll soon see that once you understand what each of the component does, you can easily create any type of graph that you want with simple commands. Okay, so some of you are probably following along. So to get the package, it is just install packages ggplot2. And then each time that you run any ggplot2 functions, you have to call the library. You have to call the function itself. Otherwise, you will not be able to use any of the function ggplot2. And this is a sample data set that I pulled from a website, so which we'll be using in this particular tutorial. I think if you look at we posted the code for the presentation. Well, this presentation is actually coded in R as well. So we posted the code up online, so you'll be able to find the data set on that in the code as well. So if you can follow along. So basically, what the data set is basically a set of data of students, their test scores, and 0 to 800, their GPA 0 to 4.0, 4.0 being the highest, and their rank in the class. And it's a really simple data set. And then the admit basically shows that whether or not they're admitted to a graduate program. So so yeah, there's different components to this data set, but that's not the most important part. Our most important goal here is how to visualize this data set using ggplot2 package. And basically, just a short intro to the data frames. So ggplot2 is particularly based as data. So each of the data set that you input into into RStudio are data frames. So you can. So you input the data frame using the read.csv option, and then by selecting each of the components, like you can see how many students have GPA greater than 3.8, and how many of them were admitted. You can use some of the functions shown here. Yeah.
Where did you get the CSV from?
Oh, it's a website.
Okay.
Yeah.
It's on the slides. Like,
The slides are actually changed to the HTML page, so we just run it from the slides from the.
oh, okay. But yeah, I actually saved it in my own local files, but it's not up on the event page. But yeah, but if you look at the code for the slides, there should be a link in there that directs you to this particular file. Okay, so to do a regular scatter plot in R, this is done in R-based graphics, so the plot function. So I graphed GPA versus test scores to show that if there's a correlation between a high GPA and a high test score on a standardized test. And the coloring just basically shows you, like, if a student is ranked 1, then it's a black color, and if it's ranked 2, it's a red color. And then so if the rank 3 is blue and rank 4 is green. So you can see that it is a little bit messy, and you will not be able to tell which students is a rank, which rank they are. And there's definitely like no relationship between GPA and test score that we see in this point. But the point of this is so that's the code to show you how to do a typical scatter plot in base R graphics. So you specify the colors of each of your each of the ranks. So like rank 1 is blue, black, rank 2 is red, and then 3, 4 is blue and green colors. And then you plot it using the plot function, and you have a legend. So that's how you do it in base R graphics. And we will show you how to do it in ggplot2.
So like the dollar sign's a selector then?
Yeah.
Cool.
So it selects that particular column. Yeah. And then, yeah, so then like the second line, the plot part, amid $ GPA, that's like the x-axis, and then the test score, that's your y-axis. But the $ selects the particular column.
Why do you need S numeric?
Oh, because like we want to change them to like different factor levels. So like the rank right now is like 1, 2, 3, 4. I don't think you can. I don't think you have to do it as numeric, but sometimes they might put it as a string. So.
So I'm just asking because I don't know what it does. So.
Oh yeah. So like, because when you input into a data frame, some of the factor levels, like if it's like a categorical variable, it might be inputted as a string. So even if you write 1, so it might be a string. So as numeric, change everything to numeric values. So that's how you do it in base R graphics, but the tutorial is to show you how to do it in ggplot. Okay. So to produce the same plot in ggplot2, you can see that code is considerably shorter and much neater. So all you have to do is to have the package, the library ggplot, and to create a scatter plot, you just say ggplot, and then you have your data, which is the innovative data set. And the AES, that's, that part is called aesthetics. So it's basically defined as aesthetic mappings that describes how variables in the data are mapped to visual properties of the geoms. So instead of the aesthetic brackets, you have your x and y axes as GPA and test scores. So as you can see here, they don't even have to specify which particular column, like the $sign. You don't have to specify which column that you're looking for directly. So all you have to do is say, oh, X, I'm looking at GPA, and Y, test scores. And the call, that's instead of aesthetic, that's your color. So because we want each rank to be a different color, so like before we had like, we actually had to specify we actually had to specify color as to numeric amid $sign rank, but now ggplot basically automatically does the color for you at the very end, which is the color function. And then the 2 additional statements at the very end of this, geom point, you can specify the size of your points on the plot. So that's one additional feature that you can use. And then xlab, ylab, and ggtitle, that's explanatory, so that's just GPA, test scores, and the title of your plot. So this is much neater, and once you do that, it looks like this. So it definitely looks a lot more professional, I guess, than the R-based graphics, because the R-based graphics are particularly used in statistical setting, and especially if you want to present something to industry, especially on your co-op terms or in your full-time work. I think that to present any type of data visualization with ggplot2 is a lot more neater and useful than, much more neater to look at, professional than the R-based graphics. So this is the plot that was created by the code that you've seen previously. So although the color is selected automatically with the color function, so like you see the call equals rank, you can actually specify your own color scheme. You can specify your own color scheme if you like. And the only problem we see here is that the rank is, the colors are based on a continuous scale. So like if it's rank 1 to rank 2, then it's like the color scheme actually changes like a gradient. So you're not specifying everything as a discrete scale. So in order to make the rank like a discrete variable, so like 1, 2, 3, 4 as its own category, like the as.numeric function does, you have to specify one more. So before we see that under the color, we have call equals rank. So now in order to specify which particular rank that a particular student is in and which particular level that they're in, you have to transform them using the factor function. So factor rank. So that basically transforms each of your ranks to different factor levels instead of looking at a continuous scale. And then after you've done that part, the only addition that was different from the previous slide is the scale color discrete. So what that does is that because you're looking at because your color scheme that you're looking at was at a continuous scale, the discrete function allows you to specify each of the dots by factor levels instead of 1 to 4 continuously. So in the end, this is what it looks like. So as you can see, the factor levels that you created with the rank, it converts all your legends to a discrete level, so 1, 2, 3, 4 instead of continuously. So if a student that's ranked 1, that's going to be shown in red, as opposed to before it was like everything between 3 and 4. It's gradually the color changes to light blue.
Is the color assigned this time you picked, or it's automatic?
Automatic.
Oh.
That's why, yeah, it's automatic. You can pick them yourself as well. But I think the automatic feature is actually really good to answer that question, because like before we had to pick our own colors in. Yeah, we had to pick our own colors in art-based graphics. You gotta say, oh, which color goes together, and then so that does take some time. So this is actually really easy for you to pick out, and so it actually automatically does that for you.
And what's the data type for the factors function, the output?
You're asking what the factors are.
Well, the data
Factors are
type.
data type, where basically assign different levels, and to each level it assigns a name. So it's thing is a very discrete case. It's supposed to be meant for categorical variables.
So it kind of treats it like, I don't know, you can kind of think of it like a string, so it's like different categories. Instead of thinking, oh, where rank 1, that's a discrete integer value. So you had to treat that more like a string, kind of like a category. So that's what the factor level does.
Unlike strings, though, they're stored efficiently as integers, so you can perform operations. on
Right,
them very
yeah.
quickly.
And then one more thing that you can add based on your code is that you can specify one more dimension to this data, is the shape. So meaning that if, because the data set had if the student was admitted or not admitted to their graduate program of choice. So in this case, if the student is admitted, then we can specify a particular shape. So instead of displaying everybody as circles on the scatter plot, we'll display if the student is admitted. If yes, it'll display like a triangle. If no, it will be a square. So in the end, the plot is completed by the scale, shape, discrete function. So you can just say, okay, but based on the admit data, if it's admitted and it's one shape, if not admitted, it is another shape. So that's what the second part of the code does. Yeah, so you can see there's a big change to this now. So we added a further dimension to this data set, meaning that if the student is admitted, it is a triangle shape. And then you can see that in this data set, you can actually visualize to see if the student admitted, what is their GPA, what is their test score, and what is their rank in the class. So you see all 4 dimensions in this data set very easily based on the shape function. And if it's not admitted, the student will be assigned a regular circle. So all of this is done automatically based in the ggplot2 package, instead of using the base R graphics where you actually had to assign each shape using the PCH function, or the size of your points using the CX function within your plot. So everything is done automatically based on scale, shape, discrete. So you don't have to even specify your shape. The third plot is really simple. So this is the bar plot. It builds on the same idea as a scatter plot, except that there is a new type of function that is created called geom bar plot. Yeah, geom bar. So it looks almost exactly the same as the previous code that you've seen for the scatter plot, except that because everything is grouped by rank, so we see how many students are at each rank. Instead of in the first line of code, you see that on the x-axis is the factor level rank, so 1, 2, 3, 4, instead of a continuous variable based on the GPA. And then the fill is basically the color of your plot, so like it automatically assigns a different color to each rank of students, so you can see on a bar plot. And then the only difference with this, the other difference with this particular code and the previous one is that you specify geom bar, which allows you to create the bar plot. And the one thing to notice that in the geom bar function, there is a width. So that specifies how big that you want the bars are. If you don't specify how big that you want the bars are, it will actually kind of look like a histogram in this case. There are actually going to be no spacing between the different bars. So that's one thing that you have to watch out for. So by now we've introduced some of the different types of scales that we've used. And there are a lot of other different scales besides scale fill discrete, scale shape discrete, which we saw that automatically assigns a shape to particular student if they're admitted, and if they're not admitted, that assigns another discrete shape. And then scale color discrete, that just assigns a different color to each factor level that we've seen. And then there are many other types of scale functions, which takes a similar format. And that's based on scale x, and y. So this is basically a chart that shows you the different types of scales that you can have. So the color, and discrete, fill, line type, shape, size. So it's like a reference sheet, so there's the different types of things that you can do with the scale discrete or scale fill discrete functions. So you can specify all of that into your code if you like. Feel free to stop me if you guys have any questions. So the third plot that we'll be introducing is the stack bar. So that adds on another further dimension to the bar plot. So as you can see, we're kind of building up on the different plots that we're creating. So we started off with a scatter plot, which we've seen how it's done with the regular R-based graphics. And we've done a bar plot, which is actually very simple. And now to build upon the code that was shown with the regular bar plot function, this is how you will create with a stack bar. So this is basically shows you how many students in each rank were admitted. So before at each rank, 1, 2, 3, 4, we only showed you how many students there were. Now we actually want to see how many of these students were actually admitted to their program of choice. And to create this type of plot, what you do is you add one further dimension to this.
If you press the top button, it gives a little light, a laser pointer.
Oh, really?
Yeah.
Oh, okay. That's good. Right, so the difference here is that because we have the stack bar, we have to specify how many students were admitted and how many students were not admitted. And basically, instead of filling by rank, which we saw earlier, so here you see the fill equals factor admit. Before is factor rank. That's the difference here. The factor rank basically allows you to specify how many students were in each rank, but the factor admit actually breaks up how many students were in each rank to admitted and not admitted. And then everything all stays the same. Now, like I mentioned earlier, without specifying the width of your bar plot, it actually kind of looks like a histogram. So the next plot that we'll be creating is a histogram. So before I want to introduce the idea of the histogram and how to create it in ggplot2, there are two types of functions actually in ggplot. One of them is the qplot, the other one is the ggplot. So both of them are actually create the same types of graphs, but qplots specify less dimensions and the ggplot functions. So you can use both interchangeably, but preferably you should use the ggplot function instead of the qplot, because ggplot you can actually specify more colors, more factor levels, as well as the different types of graphs to be created. But you can also use qplot as well. So I introduced qplot here because I want to show you how to use the qplot function to create a histogram. So So basically, this is the same data set, but now it shows you how many students were in each range of GPA. So this is, the bins are broken down by 0.1. So it's all the way from 3.0 to 2.0 to 4.0. And this graph is created with the ggplot function. It's a ggplot. So the ggplot function looks almost identical to the ggplot function, except that the difference here is that instead of adding every dimension by the plus sign, this one creates a plot the entirety of your plot, like how you would do it in R-based graphics. So everything stays the same. So instead of before we have seen geom bar function for the bar plot, so here it's geom histogram. So it's specified directly within the function itself, rather than outside of the function. And then the bin width basically specifies how big your bins are, so it's 0.1 for each GPA range. And this is how you would do it using ggplot function. So, like I said, the ggplot function does have some limitations, like specifying specific gradient colors that you want on the plot to get a more professional feel to this. So that you can also use the ggplot function, like we've seen earlier, to create the histogram. So it is essentially the same as the rest of the graphs we created, with the only change is the geom histogram function, where you are allowed to specify the bin width and the fill. And then the fill count basically creates a single color based on if the number of students were, if a large number of students fell into specific ranges, then that particular bar will be darker than the other bars. So that's like a gradient fill to this. And then for gradient fill based on different colors, you can use the scale fill gradient function. So also one of the scale functions where based on the number of students, so if the count is very low, then it's created using a green color. If it's high, then it's a red color.
So what does AES do? I keep seeing.
So it's like the aesthetic mappings.
Aesthetic, it stands for aesthetic.
Yeah, it stands for aesthetic mappings. So where you have the XY axes, where you can specify your colors and based on different factor levels. So you don't technically see this in the base R plot because you create the colors yourself, you specify the shape yourself, the size of your points using CX or PCH, and you don't do that. You don't do that in ggplot. You can do that directly within the AES function. But it all depends on what type of graph that you're creating as well. So that's what the plot looks like from the previous slide. So the gradient that we created at the very end using scale fill gradient with the low count and the high count red, that basically specifies how deep that you want your colors to be. If you were to do this same type of analysis with the regular R-based plots, then you're probably going to look at additional coding based on the colors that you wanted, rather than a simple specification. We will also go over the box plot. So this is the box plot that is created with the ggplot package. So the only difference with this plot and the previous plots that you've seen is the specification of the function from a particular graph. So before we've seen geom bar that specifies, or geom histogram that specifies the type of plot that you want. But here is geom box plot, so everything else remains the same. You're able to completely change your code from a previous plot to the box plot set very easily, instead of specifying what type of box plot you want in base R plots, which are a lot more complicated than in this case.
when you have this plus, is this like adding a property?
Yeah, you added some property to it.
Okay.
So like, unlike the regular R plots, which kind of looks like the Q plot function, but without the Q, but without some of the geoms there, where you have comma and then you add all the different properties. But the ggplot, to specify the different properties, you use the plus sign added in, instead of using everything in the same bracket. And then, of course, you can write like all lines of this code, like his plus, all lines of this code in one line if you want. Like I only showed it in 2 lines to separate out and more clearly to show you what each part of this plot does, like the different titles and the different, yeah.
I believe also the way it's structured, plus, it makes it very flexible. So everything's modular, so this changes that, changes this, so you can stack on many different things.
Yeah, for sure, yeah.
So are you able to change property afterwards, like to see what's the value, for example, to access the property that you have stored?
Like from, like so say you want to see how many, like how many students were admitted or not admitted, like see it on the breakdown by bar. Yeah, I believe you can. Let me think. I believe you can do that. Either probably not through the ggplot2 function, but you can do that by specifying the data frames directly. So like at the very beginning of these slides, I had a section on data frames where you're able to sort through the data frames and show you how many students had were admitted and had GPA over 3.8. So you can directly count that yourself, or you can look through this through ggplot2 as well. But I think it's easier to just write the code command by yourself than looking through ggplot2. So it's at the beginning of the slides. Right, and then the only other thing here to notice that we also use the skill fill discrete function here, because we specify the admitted data, if the student was admitted, then we give them a label, no or yes. Now, if you actually don't have this line of code that shows you skill fill discrete, admit yes or no, then the difference here is that if you actually don't have that line of code, what you will see instead of the word admit instead of seeing the word admit or no or yes, you will automatically see something like 0 or 1 and then factor admit. So if you don't want code to show up on your plot, you have to specify something like skill fill discrete and name each part of your plots. So that's the important part of that particular function. We also have, besides the other graphs that we've shown, we also have some time series and regression analysis. You can also perform this in ggplot2. I know a lot of the regression analysis that we've done, and maybe in Stat Switch Rewind and some of your linear regression courses are done in the regular R plots. You can do a lot of these advanced graphics in ggplot2 as well. Some of these functions can actually automatically do model selection for you and plot it directly on the graph using some of the ggplot packages. So basically, this is basically an economics data set from one of the R packages. So it's actually called economics. So if you do head bracket economics, so like. If you actually want to see the data set, it's like this. But that's the data set we use. It's actually within R. It's like a package. It's like a data set within R. So it's not the one I downloaded from the website. So that just shows you the first 5 lines of that file. So to create a line plot, it essentially uses the same idea as the previous plots that we've had. So like the bar plot, the line plot is similar, except that we use the geom line function. Of course, you can have various other aesthetic mappings within this function as well, but for now we've kept it simple with just geom line. And basically this specifies, this graphs this entire data set into a line plot based on x-axis as your date and y is the unemployment rate. And everything else remains the same as before. So that is something that is created using the ggplot line function. And then to perform some statistical transformation to this series, to create that line that you see across and to see the trend in unemployment rates throughout the years, you can use this function, which is a geom smooth function. So this is basically ggplot's built-in model fitting tool that allows you to plot the fits from any model of your choosing. So you can use this to directly plot linear regressions on your plot. So this is not a linear regression, obviously, but by specifying the geom smooth function, by simply adding geom smooth at the end, it creates that line for you to see the trend in the data that you're looking at. So it's much simpler to specify rather than using rather than performing your own model selection using the base R graphics.
So can you now see the coefficient, for example?
No, not in this case, no. It just visualizes the data set. Actually, I think for the line plots, I think you can. For the line ones, I think you can. I think you can see the coefficient of line ones, but I'm not too sure on that particular one. Yeah. So yeah, this one is basically the line plot based on geom smooth. Besides the various other ggplot plots that we've shown, so we've seen the bar plot and how that's built up to a stock bar, and then how that's built up to a histogram, and then we've also seen the histogram and specifying what the different various other layers look like, the different colors and the different shapes by just changing your aesthetics by one parameter, like the different factor levels, by specifying like scale, fill, scale, shape, discrete, scale, fill, discrete, you'll be automatically selecting colors based on the ggplot2 function, and everything else is done automatically instead of specifying your own shapes and color itself. Besides that, there are some other options and tips that I think are quite good, which I found while working with ggplot2, which I knew when I started this. So one of these things that I wish I knew when I started ggplot was the par for this function. So if you're familiar with R, this function, what it does is that it basically puts your plot in a layout format in a sheet. So that line of code, actually, if you're not familiar, it's like, I'll draw it over there. So like param C22, so what it does is that, like say you have like so this divides your page actually into 4 corners, and then you can actually create 4 plots, so like 1, 2, 3, 1. And then if you have like 3, 2, then it's like 3, 2. So it's like by or 2, 3 in that case, then it's like by row and column. So it specifies how many of these graphs to put in one page. This is in R-based graphics, so you have a lot of plots to plot. Then you can actually loop through your plots and create these graphics easily based on that function. But what I found was that if you're trying to create this in ggplot, ggplot doesn't actually have the par and C function. So you can't actually create several ggplots on one page. So meaning that when you don't have that function, you don't know how to specify how many ggplots to plot in one page. So one of the other things that users online were producing is a multi-plot function. So this is just a user-defined function. You can check out the code for it later. It's in the slides. So in the slides that we posted. So basically, it is this function that allows you to plot multiple plots in one page, so that you don't have to use the par and pro C function to do so. And then this basically plots the same idea as par and pro C here. And there's other functions that I know that also does the same type of graphs as this, and you can also search through them online. But yeah, in general, you cannot use a similar type of function as par and pro C in ggplot. So the other thing I didn't talk about was how to control the limits of your scale. So if you want to do x and y, the limits are also done using the same scale function that we've seen. So scale fill discrete, scale color discrete. So this is like scale x continuous, scale y continuous. So basically it specifies what is your limits on both an x, y scale. Or additionally, you can just use xlim or ylim, which is the same thing as you see in the regular plot function in R. So you can also specify adding that to your ggplot. You can specify what is the limit on your plots as well. And then to specify like choosing x and y axis breaks, so meaning like how many ticks that you want to appear. So like if you want to take out 1, 2, 3, 4, 5, all the way up to 10, then you can use the x scale continuous by making breaks from 1 to 10. And each tick is 1 and then all the way up to 10. And then the cool thing that you can do here is, this is basically a data set on like the ratings of a movie and how many people voting on them. So like if you see like a rating of 2, then it's horrible, and then if it's like a rating of 5, that's okay, and then 8 is awesome. So instead of actually specifying like, so if I'm lucky about my breaks at 2, 5, 8, you can actually specify, oh, 2 is horrible, and then 5 is okay, and then 8 is awesome. So you can also do that with ggplot2, which is something that you don't necessarily see with the R plot function. So this allows you more control in the scale x continuous. So there's actually a lot of nuances that actually do go on in that particular function, like the scale x continuous, scale discrete fill, and scale color discrete. So it really depends on what you're looking for in that particular type of plot. And this tutorial itself will probably not cover all of that, all of these uses of when to set the breaks, when to set the labels. And it all really depends on the data set that you're looking at. So, and you can search up the documentation for the various types of scales to use, which I have a slide in the middle that shows you the different types of scales that are available that you can use in this particular case. And then because you're also using the, because the par and pro C function, sometimes when I was performing graphing large amounts of data or multiple graphs in a page, you will find that sometimes your page does get overcrowded. So sometimes you want to remove you can also remove the legends in here. And then so by specifying no legend here, then then you can choose not to show the legend on a particular plot. And then, so there are some other links to the other resources that are part of the ggplot that you can, so this is basically a tutorial, basically the introduction to the various plots that you can create in ggplot2. So these links, the cheat sheet that you received, shows you some of the more advanced ggplot functions that is within the package. But most of the time that I actually find that you don't necessarily get to use a lot of these functions, especially if your goal was just to visualize a set of data and see how the data set change from over time, especially historically. So even with large amount data sets, some of these functions, I don't find it that you use quite often, but there's a link at the end to the cheat sheet. And then also color selection. So you, instead of using ggplot2 to actually specify the different colors, you can actually select your own colors. So this link will go over all the color names. It's actually quite interesting instead of specifying different hex values for each colors. So this actually goes into the different colors that you can specify. And you'll be actually surprised to see that actually selecting colors is actually very important. So it's actually very important. So yeah, you should probably take a look at that. And then basically, and the final link is basically an anatomy of a plot. So this basically shows you the various aspects of the different functions that we've gone over. So like the different scale x continuous, scale y continuous, and the various other functions that are part of a plot that we haven't gone over here, and it's all in this link. So you will able to see what a ggplot looks like as compared to a regular R plot. I think that's it. I think that's it. If you have any questions, feel free to ask me. And if you have any questions about the code itself, I can help you set up that in R Markdown. So basically, this entire presentation is created in R as well. So everything is so the code, like everything is created in R. So everything is like all these texts are in R. So you can automatically generate it as an R presentation on your own computer. We'll post a link to the CSV. Yeah.
So can you talk a bit more about this idea of the grammar of graphics? What does that mean actually?
ggplot2 is based off a book called Grammar of Graphics, as basically how to think about graphics. That's the reason why there's aesthetics, there's different shapes. It's based off all of those aspects. So that's why it's called why ggplot is very well connected to the term grammar of graphics, because that's the philosophy behind ggplot is.
And like I said, like you might think that color selection is not important, but it is actually really important. You'll be surprised how many times I've heard people say that blue and red doesn't go together, and how do I pick these colors? And yeah, in the regular R plots, you actually have to pick these colors yourself. But ggplot2, these colors are picked automatically for you. So sometimes you do, yeah.
I just want to point out the color selection is actually really important, because it helps differentiate various items. So if you have a very good plotting scheme, you could save lives. If you're going in health, you can save lives by picking the right color scheme.
Yeah, and especially if you're giving a presentation to a senior management or a board, it's actually really important. Colors is really important, trust me. So yeah. Yeah.
So have you tried other visualization packages like matplotlib for Python or d3.js?
I've heard of them, but I know what it can do, yes.
Okay, so like, when would what does ggplot do better and worse than those alternatives?
I could supply that. The advantage of ggplot is it's very modular, so you could change the aesthetics as much, very much more flexible than matplotlib or generic rplot. So you could manipulate the graphics the way you want it to look like, and yeah, that's the power of ggplot2. Is the custom building.
Modularity, basically, too.
Yeah.
You can set up kind of your own little grammar for how graphics should look. You can set up but basically it's like objects, right? When you're summing those objects together, you're actually combining them, all their aesthetics, all their components, etc. And you can make a set of objects that you use frequently to visualize a given set of data. And it's just really fast for that kind of thing. At Matplotlib, I find I end up spending a lot of time just setting up the same kind of stuff over and over again. Maybe mind handling in Python, but that's my experience.
d3.js?
Just one more point. There is a module called ggplot for Python as well. It's based off around ggplot2. So it's Python is trying to get a version of ggplot2 out there.
Yeah.
Would you be able to use ggplot2 to make like heat maps or like
Yeah.
multi-plot?
Yeah, you can do
That's
that.
doable, right?
It's doable. Yeah, it's possible.
Just because the fact that it'll choose good colors for you for your heat map.
Yeah.
That's better would be perfect.
Yeah, for sure. Yeah, you can do that.
So what about animations? Can you do that in ggplot2, or is that?
I don't believe so. Do you mean like a WPF GUI you do in Java, like swing package, or?
No, like, so like, you want to transition between two views, right?
Okay.
So you have a view where you're like plotting all the males, and you want a view when you plot all the females, and you want to just transition between the two activity, the bubbles, the radio buttons.
There's other packages for that.
Okay.
I think Shiny is actually pretty good with that too.
Yeah.
This was that?
GGBiz.
Yeah.
Any other questions?
So what exactly is a geom? And,
So it's like, so basically it just allows you to specify like in this regard it's like a name to specify the different types of plot that you want to create based on the different data points. So it's like a specific syntax that is particularly used in ggplot2.
so each geom has the same set of aesthetic mappings?
Yeah, so like meaning that like so like so like in the geom box plot you can specify the aesthetics, and then in the geom bar plot you can also specify similar types of aesthetics. Yeah, so it's based on the plots that you want it.
Similar but not the same.
Well, yeah, similar, not the same, but it really depends on the data set you're looking at.